Shri Gurubhyo Namaha, children. We'll continue with one more numerical from Wheatstone network. The numerical which I am going to do is in page number 128, children. Sum number 3.9. Now, last topic we read about Wheatstone's network. So, I want you to continue with the same topic. When we do the sum, hope the concept will be much more familiar for you. Okay, so let us move on to this sum. Let us read the sum first. Determine the current in each branch of the network shown in figure 3.30. Okay, now look at the circuit here. Now so many resistors are there, and you have a EMF whose value is 10 volt, and that is connected to a bridge of resistors. Now how many resistors are there? Here itself we have one resistor, and you have 1 2 3 4 5. Apart from that you have 5 resistors in this network. So we need to calculate what is the current in each branch of the network. Okay, so now here the current is not named, so we need to first write the current in each branch, right? So let us start from here. Okay ma, so this is a battery. Now this is a positive terminal of the battery, so let me write this as plus minus. Okay, so current starts from here, so let me write this as I, children. Now from this junction the current is getting splitted up, so let me name this as I1, let me name this as I2. Okay ma, now after that here again this is a junction. Now here let me name the current as I3, children. Okay, so if this is going to be I3, if this is going to be I1, then this will be I1 minus I3. Okay ma, right? Then here it is going to be I2 from here, it is I3 from here, so this will be naturally I2 plus I3. Okay, and here the current is of course I. So I have named current. Now the loop is already named A, B, C. Now this is D. So this is D. Now here I have E. Now here F, and here it is G. Okay. Now let us solve the problem. Now let us write the correct currents first. So let I1, I2 and I3, okay, be the currents. Okay, right. Now applying current law at junction A. Okay, so where is the junction? Look at the diagram. Junction A is here, children. Now the incoming current at this junction is I. The outgoing current is I1, I2. So when I write the algebraic value of all these things, I have I1, sorry, I plus minus I1 plus minus I2 equal to 0, or I is equal to I1 plus I2. Okay ma, so this is the current that is entering and leaving as far as junction A is concerned. Okay, now let us apply voltage law. So applying voltage law, now we need to have a closed loop. So what loop shall we have? We will start from once again A. So let us have A, B, D, A. Okay ma? Right, now I am going to write very easily the value of, that is the product of current into resistance. Look at this loop clearly, children. Look at, try to listen very carefully. Now A, B, D, A, this is the loop, right? Now the current is starting from here. The arrow starts exactly correct. This is the because we consider the starting point to be A. So A to B, the current direction is this. Then actually it should be from B to D, the current direction exactly. So it is also in the right way. But look at this lead, children. Look at this lead. Actually, as far as this loop is concerned, you have to start from A, B, then C, D to A it should go. So A to B it has gone correctly, B to D it has gone correctly, but instead of D to A it is coming from A to D. So in this case, when I write the product, I can have a negative. I remember easily, I'm telling you a very easy method. See here, current direction exactly correct from A to B. Then from B to D, it is right. Now it should be from D to A, but it is from A to D. So when I write the value here, I will have a negative sign. Okay, clear? You understood now? So let us start writing now. What is the product of current into resistor in this lead, children? In this lead, it is 10I1. Okay, ma? So 10I1. Again plus I will have. So I1 let me write. So plus BD, current is I3, resistance is 5. So it is 5 into I3. Now both I have written positive. Now when coming to this junction, it should be from D to A, but it is not from D to A, it is A to D. So I will have a minus sign here. So what is the product of resistance into current? It is 5 into I2. And you don't have any EMF, any cell there. So it is 0. Okay, so let me name this as equation 1. Right? Next page will go because okay, now next loop, what we are going to consider is, keep on looking at the diagram very clearly. I'm going to take the loop, this one. So it is B, C, D, D and B. Once again, I'll tell you B, C, D, B. This loop I'm going to consider. So let us see the arrows. Start from B, children. So starting from B, the current is moving from B to C, correct? Okay, so product of current into resistance, I will write this with a positive sign. Okay, ma? Next, from C to D, look at the direction, children. C to D, actually it is from C to D, but here it is given from D to C. So what can I have here? When I write the product of current into resistance, I will have a negative sign here. Okay, ma? Right, next, again from it should be D to B. Again, the direction of current is opposite in the direction. So, when I write the product of current into resistor here also I have a negative sign. So, first alone I have a positive sign. The remaining I will have a negative sign. Okay, ma? Now, let us write the equation. Applying voltage law in the loop. What is the name of the loop? B, C, D, B. Okay, ma? So I will have 5 into I1 minus I3 minus 10 into I2 plus I3 minus 5 into I3 equal to 0. Look at the diagram. Now this is I1 minus I3 into 5 ohm. So that I have written first. Okay. Right. Then here the direction of current is in the opposite direction. So it is I2 plus I3 into 10 with a negative sign. So I have written here. Okay. Then again it is 5 into I3 with a negative sign. So it is minus 5,3 equal to 0. Okay, now simplification. Now here it is 5I1 minus 5I3 minus 10I2, again minus 10I3 minus 5I3 equal to 0. Okay, so let us segregate all the terms, children. I1, I have only one term. So I will write this as 5I1. Then I2 also I have only one term. So it is minus 10I2. Now here I3 I have minus 5 I3, minus 10 I3, minus 5 I3. So minus 5, minus 10, minus 15, minus 20 I3 equal to 0, children. Now divide this. So I have I1 minus 2I2 minus 4I3 equal to 0. This is my, let me know what is the equation I have named here. Now here it is 1, so here it is 2. So this is my second equation. Is it clear? Is it clear now? So I1 minus 2I2 minus 4I3 equal to 0. Okay, now I am going to take the third loop. So third loop I am going to apply voltage law, applying voltage law in the loop. Okay, now which is the loop I'm going to do? I'm going to take the loop starting from here. A, D, C, F, G, A. Again I will come A, D, C, F, G, A, because I need to find out 3 values of current, 4 values, I1, I2, I3. So I is here. Okay, so I need to consider this loop also. So I am taking this third loop. Okay, so it is A, D, C, F, G, A. So let me write that in the loop A, D, C, F, G, A. Okay, now let us write the equation, children. Let us start from A, children. Okay, A to D. So it is positive because current direction is along my direction. So it is 5 into A2. Now here see, again it is correct. So I2 plus I3 into 10. Now there is no resistor here. There is a potential which is from negative to positive. So I can write plus here. Now here I have 10 into I. Okay, and here also there is no lead, there is no resistor, so I can stop from here. So all will have only positive sign, no negative sign. So easily I can write now I can write 5I2 plus 10 into I2 plus I3 plus 10I equal to 10. Okay ma? Now again 5I2 plus 10 into I2 plus I3. I have the value of I to be. I have found out the value of I to be I1 plus I2 here. Substitute that here. Instead of 10I, I substitute I1 plus I2 equal to 10. Now simplify this. 5I2 plus 10I2 plus 10I3 plus 10I1 plus 10I2 equal to 10. So let us segregate all the terms. I1 I have only one term. So let me write that first. Then I3 also I have only one term. So that also I will write. Now I2 I have 5I2, 10I2, 10I2. So 10 plus 10, 20, 25I2. 25I2 equal to 10, which is my third equation. Clear? Is it clear? Now I have got 3 equations, children. The first equation is 10I1 plus 5I3 minus 5I2. The second equation is I2 minus 2I2 minus 4I3 is equal to 0. And the third equation is 10I1 plus 10I3 plus 25I2 is equal to 10. Okay. Now you know the process of simplification. You have to take any 2 equations. You need to simplify those 2 equations to get any one value of I1 or I2. Then substitute in the first equation to get the value of the other value. So similarly, when I simplify all these 3 equations, I will get the value of current to be I1 equal to 4 by 17 ampere Similarly, I have the value of I2 to be 6 by 17 ampere, and I have the value of I3 to be minus 2 by 17 ampere. You have to get this answer. Okay. Now here is the proof. What is the proof here is, now as far as Wheatstone network is concerned, children, only the concept you have to understand. Kirchhoff's rules you have to understand. Concept, current direction, sign convention, voltage, positive, negative, current, product of current, resistance, positive, negative, fine. But the simplification process full of maths. Now these are all mathematical equations which you are going to solve. Children, you should have that passion. Now sometimes you may feel bored, but the concepts what we learn, it should be very well registered in maths, especially whenever we learn physics. Unless and until you have the passion of understanding the concept, children, then once you start understanding it, once you start liking, you should be very curious to know about things, children. Then the subject will be very, very effective for you. You start loving the subject. That is how I started loving. Because when we go deep into the subject, when you try to understand, analyze, the subject becomes more interesting. Otherwise, no. So that's why many people, they feel this subject to be bored. No, it's not like that. You have to be very, very curious enough, passionate enough to learn the subject. Each and every time, whatever line you read, please have that passion. Definitely then you will love subject, you love physics. Okay, and this is this is one of the topic which I love the most, current electricity. Very curious to know about things, very interesting to solve these type of circuits to get the equation, the answer. That is why every time when I solve some, I'll give you the answer. You have to get this answer, I will say. So once the answer is there, then you will be, when you are really interested, then you will be very interested to solve it and try to get the answer. So this is how you develop. Interest is very, very important. The passion that is there in you is very, very important. Okay, ma, so please don't miss this subject. It's very interesting. Please continue to work hard. Okay, so get this value of I1, I2 and I3. Then I'm going to substitute now. Now look at this diagram once again. Now here I have the value of I1, I2, I3. Now in this lead I have I1 minus I3. In this lead I have I2 plus I3. So I need to find out what is the value of current in each lead. Okay. So first I will find out what is the value of I1. So where is I1? So I1 is here. I1 is 10 into I1. So what is the value of I1 will be? As such, the current in the lead I of, what is this lead? Let me take this lead as AB. So current in the lead is IAB is equal to 4 by 17 ampere. So this is one direction of current. This is one value of current. Now let us go to the second lead. The second lead, now I have the combination here. First we'll write the single value of current. So here it is I1. Now come to this lead, children. Here it is I2. So let us write the value of current in that I2, which is what is that lead? What is this lead? It is AD, right? So we'll write the value of current in AD. I in AD is, what is the value of current? I in AD is I2. So let us also write the value of I2 here, which is 6 by 17A. So that also I have written. Okay, next, current in the lead BD. So where is BD? Here. Now the current in this lead is I3. So just I can write the value of I3. So current in the lead BD is, what is the value of I3? Which is minus 2 by 17 ampere. Okay, now let us go to the combination. So take lead BC. So current in BC is, current in BC is, what is the value of current? I1 minus I3, children. So I1 minus I3, substitute. So which is I1? I1 is 4 by 17. I3 is minus 2 by 17. So minus of minus. So you have the value of current in this lead to be 6 by 17 ampere. So current in the lead BC is 6 by 17. Next we have, so we have written for this. We have written for this. Now this we have to see. Okay, so current in the lead DC. Okay, so let us write that I of DC is, what is the value children? I of DC, I2 plus I3. So it is very easy, just addition only. I2 is 6 by 17 plus what is the other value? 3, I3. So I3 is minus 2 by 17. Okay ma, so I have IDC to be 6 minus 2 is 4 by 17 ampere. So this is the current along IDC. Okay, now what is the total current? One is left. Total current is I is equal to, this is separate, don't confuse. I is equal to I1 plus I2. Okay ma, so I have, what is I1? 4 by 17 plus 6 by 17. I1 plus I2. Yes. So it is 6 by 17, which is equal to 10 by 17 ampere, which is the total current. So this is how you will solve a problem. Okay, based on Kirchhoff's current and voltage law. Hope you are, we have solved so many numericals. Hope you have some idea about Kirchhoff rules. Let me try to send you some more problems, children, so that you'll be very clear in this concept, which is a very interesting topic. Okay ma, so see you tomorrow for the next class, children.